Welcome to section 7.2, where we're going to talk about how we actually find the probability using the normal distribution. So, first let's talk about how we find and interpret the area under the normal curve. So we use the following calculator function to do that. We hit the second key, then we hit the vars key, then we go to the distribution menu, so that's an arrow over, and then we're going to pick, actually it's not an arrow over because it's the menu that comes up, sorry. Then we're going to pick number 2, which says Normalcdf. Now, it is critical that you pick the second option that says CDF. Option number 1 is a P as in pencil DF. We never, ever use that one. And then the arguments it takes are a lower bound, an upper bound, and then a mean and a standard deviation. So there's a special type of normal distribution called a standard normal distribution. And so sometimes they won't give you a mean and a standard deviation. They will tell you that you have a standard normal distribution. Standard normal distributions always have a mean of 0 and a standard deviation of 1. Always. But only if it says standard normal. So let's look at some examples, and we will just use those to practice using the calculator. So, a pediatrician obtains the heights of her 3-year-old female patients. The heights are approximately normally distributed with a mean of 38.72 inches and a standard deviation of 3.17 inches. Find the proportion of 3-year-old females that have a height less than 35 inches. So first, I'm going to draw my curve. So there's my curve. And I tend to be lazy on these. I will put the mean in the middle. So that's 38.72. And instead of actually writing all my standard deviations, I'll just do this number. I'll put, and we shouldn't put it right there, I'll just put over here somewhere that the standard deviation is 3.17. This picture, is really just for you when you're doing the problem, and for me, so that I know you know what you're doing. But it's not necessary to mark everything perfectly unless you're, publishing in a journal or something. So it says, find the proportion, remember that's another name for area in this case, of 3-year-old females that have a height less than 35 inches. So 35 is smaller than our mean, so we're just going to put a line over here on the left side somewhere and label it 35. And we need less than, so that means we're going to shade this area. Now, this keeps going forever and ever and ever, both to the left and to the right. In other words, it goes to negative infinity on the left and positive infinity on the right. But the calculator can't deal with infinity. So what we do is we pick a suitably small or large number to substitute for infinity. So we're going to use, for negative infinity, let's use negative 999,999. So negative 999,999. You will frequently hear me say negative bunch of nines instead of having to say 999,999 every time. So similarly, for positive infinity, we'll use positive bunch of nines, or positive 6 nines, which means put 6 nines in. So the calculator function, to find this probability, the probability that x is less than, so that's a less than symbol without the equal to line, less than 35 is, we use the Normalcdf. Our lower boundary is always what's on the left. So lower bound, I'm going to write this down here, lower boundary is the left side of shaded region. And the upper boundary is the right side of the shaded region. So in this case, our lower boundary is negative bunch of nines. And I'm going to write that without the commas so we don't confuse things. Our upper boundary is the right side of our shaded area, so that's 35. Then we need to give it the mean, and we need to give it the standard deviation. So let's pull up the calculator and see what that looks like. So if you go to second and then VARs, and you see we're already in the distribution menu, so we want option number 2. So you can either just push the 2 button or you can arrow down, either way. Now, your calculator should do this. If it does not, then put the numbers in just like I've written here with commas between them. And I'll show you what that should look like in a minute. So we're going to clear this number out. We're going to put negative. Remember to hit the negative key, not the subtract button. 6 nines. Our upper, we said, was 35. Our mean is 38.72. And the standard deviation was 3.17. Then you just highlight paste and hit enter. So you can see it has taken the things and put them in the same order that I wrote them on the paper. So if you don't have that little screen I had, you can see it will write Normalcdf and open a parentheses, and then you just put the numbers in just like they're written on the paper and just like they show up here. Then you hit enter, and there's our probability. So again, Pearson will tell you how many decimal places to round to. For the notes, we're just going to round to 4. So the probability is 0.1203. So if we had to interpret that, we would say the proportion of 3-year-old females that have a height less than 35 inches is 0.1203. Okay, so let's use the same problem, but this time we want a height greater than 41 inches. So let's draw our picture. There it is. We have 38.72 is the mean. We have a standard deviation of 3.17. And we need greater than 41. So, I don't know, 41's right here maybe. And greater than means to the right. So we're going to use Normalcdf. Our lower boundary, remember, is the left side. That's 41. Our upper boundary is infinity, but remember we use 6 nines for that. So 999,999. Do not put commas in the 999,999 in the calculator because it will confuse it. Because it uses commas to separate these things. Then we put the mean, and then the standard deviation, and we should have said that's the probability that x is greater than 41. And so if we put that in the calculator, second vars number 2, our lower boundary this time is 41. Our upper boundary is a bunch of 9s. And our mean and our standard deviation are the same. And so we get, if we round to 4 decimal places, we have 0.2360. So 0.2360. Now, this asked for the percentage of 3-year-old females. So to actually answer the question, we would say the percentage of 3-year-old females that have a height greater than 41 inches is, and we have to change our decimal to a percent. So that's 23.60%. Okay, we will look at some more examples in the next video.